We will give it one more minute. Okey doke. I think we should get started. Thank you all for joining us. Welcome to today's NASEO State Industrial Working Group webinar. We are pleased today to host Dr. Haresh Malkani, Chief Technology Officer of the Collaborative Ecosystems for Smart Manufacturing Institute, which is quite a bit to say. It's easier to say CESMII, which we will refer to it. He will also be joined by Dr. Mark McGinley of the University of Louisville, who will join him to speak about one of the cases that will be featured. CESMII is one of 18 Manufacturing USA institutes and one of, I believe, 7 that are supported or sponsored by the United States Department of Energy. The institutes are working to advance U.S. manufacturing performance across a range of sectors, technologies, and techniques, and you will hear about efforts in smart manufacturing with a focus on energy. Before handing the virtual floor to Dr. Malkani, a few words on logistics and a brief overview of our NASEO State Industrial Working Group for those of you who may not be so familiar with us. And also, I want to take a moment to thank and recognize my colleague Sam Kramer for his support of this work too. Next slide, please. So on the logistics, please mute when not speaking. This is a Zoom meeting rather than Zoom webinar, so it's a little more intimate, and we all have the ability to chat and speak, but please mute when you're not speaking. And we should have plenty of time for Q&A and discussion afterwards, and you can use the chat box. There isn't actually a Q&A box. You can use the chat box and or just raise your hand. I think we're a small enough group for that. And we will be posting the slides and the recording. Next, please. A little bit about the working group for those of you who aren't so familiar. We're supported by the Department of Energy. We're very fortunate for that, to work with the states to help state energy offices and others to identify, develop, and enhance resources to advance manufacturing and wider industry. We're working to enhance the cooperation and coordination exchange across technical assistance programs, business assistance programs, and we seek to support economic development and productivity, environmental and energy reliability and resilience objectives of firms and of states. We are working on helping strengthen existing industries, as well as interest in advancing new technologies and new industries. Next, please. As of now, we have about 19 states participating at various levels, mainly through their state energy offices, but also through other agencies and programs. We have participating economic development agencies and authorities. We have some technical assistance programs also participating in this. And any of you who are not currently participating, who are from states or the public sector or from TA providers who are interested in joining us, please let us know. You are more than welcome. Next slide, please. So a little review of our work. We do provide web resources and email updates on technical and business assistance programs, on funding opportunities, on recent reports, studies, tools, and organizations, and on events. A few recent ones to highlight are listed there, including a recent CSIS report on critical minerals. Not usually, we don't cover so much critical minerals, but we're getting a little more into that, certainly the processing and manufacturing aspects. The DOE's Better Building Better Plants Summit is coming up this week. A reminder of the Industrial Training and Assessment Centers program, that there are grant offerings, and that is on a ongoing basis. Applications are being accepted. A few events and resources from other organizations to highlight. The Renewable Thermal Collaborative will be having their summit in October. That's quite a ways off, but mark your calendars. We've also listed a recent utility engagement playbook for industrial customers that we commend to you. A reminder of our NASEO overview of industrial technical assistance for states. We point to some Department of Energy, RMI, and again, Renewable Thermal Collaborative resources. I think Neil, we have, I think, ACEEE reports as well on our webpage, to which, yes, you're quite welcome, which we alert our members and the wider community. And we also want to point to a newly formed Thermal Battery Alliance. Next, please. So some other activities. Some of you on this may recall our last webinar in January, which was focused on Pennsylvania and the Pennsylvania RISE PA program, as well as technical assistance offerings. Prior to that, we had a forum focused on industrial heat electrification and storage. We also had earlier last year a focus on industrial demand flexibility and a forum on state and local pollution prevention programs and small business environmental assistance. I also listed a response to a DOE request for information on transforming industry, to which we contributed. We are very interested in your views on potential topics for future webinars and forums. A few our possibilities are listed there. And we are also very interested in your state's case studies, experiences, different organizations, and we love to share the great work that you're doing and have peer exchange. And I think with that, I will hand it over to Haresh to tell us about CESMII. Please go ahead.
Thank you, Rodney. I'm just going to go ahead and share my screen. Incorrect one. There we go. Okay, assume everybody can see the screen and can hear me all right.
Yes, very good.
Thank you for the introduction, Rodney. I've been with CESMII for about 7 years now. When I started with CESMII, I thought maybe I'll hang around for a couple of years, and now it's been 7+ years, so I must really like what I do. Prior to that, for about 30 years, I was in industrial R&D with Alcoa. They have a research and development facility just outside Pittsburgh. That's where I operate from, even in my current role. And a lot of my work has been in the area of what's now called smart manufacturing, but it's all the integration of things like sensors and predictive modeling, advanced control, and so on. So what I'll do today is we've been in existence for about 7 years, as Rodney said, one of 18 manufacturing US institutes. Our focus is on smart manufacturing, and what I'm going to describe is, first of all, what smart manufacturing is, just to sort of level set and make sure that everybody understands what we see smart manufacturing as. CESMII as an institute, what we do, what our strategy is around the 3 pillars of technology, education, and ecosystems. And then spend roughly maybe half or a little less than a half of the time maybe walking through some of the relevant examples for this particular audience. So that's what we'll be doing today. And within the use cases, one of the projects that we've done is around smart manufacturing in cement. And I've got Professor McGinley here today with me who'll talk about that particular case. So smart manufacturing, if you just look at the definitions that are out there, you'll probably get multiple definitions depending on who you ask. CESMII decided to use the following, which is highlighted in the yellow words, that is the information-based, event-driven, efficient, and collaborative orchestration of business, physical, and digital processes. And this can be within the plants, it can be factories, it could be an entire value chain in there. It's not the street definition of smart manufacturing. So if I'm explaining this to my wife or my family, I would say that it's the right information at the right time, in the right form, in the right place, with the right technologies, so that the right people or the right machines can make smart decisions. So the one-line tag is it's information-based decision making. Right? That's how we see smart manufacturing. Where the information comes from, how it is used, is all the magic behind the scenes and the real crux of what smart manufacturing is. The way we put together the framework around what are the different building blocks of smart manufacturing and what each piece does and how it connects with the adjacent piece is through this particular diagram. And if you focus on this slide, it's basically 4 quadrants, actually. If you look at the bottom left, it's all about the descriptive analytics, meaning that you need to know what's going on. And if you start there, the first thing you do is in your manufacturing process, you will have some way of measuring what you're doing. So you've got sensors, and you could have advanced sensors. And one of the examples that I'll show you is a sensor did not exist for that particular use case, and we helped fund the creation of that sensor. And then once you get the sensing done, you're basically creating data, and that data can be immediately used for control purposes if it happens to be something that's fairly straightforward and simple. So for example, speed control, tension control or something like that in a piece of equipment, then you can immediately use that data in a control fashion, right? But more often, data comes from different places in your manufacturing operation, different sensors, different parts of the process, different parts of the equipment. And therefore, what becomes important is something called contextualization. So that provides you with the context of what you're measuring. So if you're measuring temperature, it is on a part that is being manufactured on that machine at this particular time, at this particular phase in the operation. That's all context. And that's really, really important, and it's really, really powerful. So once you do the contextualization, you're converting that into actionable information, right? And now, once you have this, you can start doing your analytics on that information to become aware of why things are happening. So this is more about the diagnostics around the information. And at the same time, if you take this rich information and feed it back to your control system, you're able to control the process a little bit better than you did before when you were doing it in individual segments. The next piece is on the top right, where we now go into the world of figuring out how do we predict this. So once the analytics are done, you develop the insights, and then you start doing predictive modeling based on that information. And this modeling can be data-driven. It can also be physics-driven or chemistry-driven. I've been corrected once on that language. But once you've done that, then you have the intelligence to provide the control system enough information that'll make it act proactively, right, before the condition occurs. So how do you make a change to the process so that the bad things that are happening don't occur and the good things that are happening can be made to reoccur? So that's all about the prescriptive world. So when you look at this, you can see that smart manufacturing could mean different things to different people. If people come from the world of AI and predictive modeling and neural networks and all that stuff, they're looking at the right-hand side of this picture. But a lot of the small manufacturers are still doing a lot of good, intelligent, predictive, smart work just based on figuring out what's happening and why it's happening. and just the visual information is sufficient for that. Another important piece is that you could have this solution set up for one particular use case, but then in order to proliferate that, you need some sort of an infrastructure that's based on standards so that you can replicate the solution. And for that, it's essential that the information that is going from the bottom left to the top right and back is all done in context and in a standard way, so that the person who's developing the model doesn't have to worry about whether this data is structured in the right way or not. It's always going to be structured the right way because that's how we've been trying to proliferate the infrastructure pieces of smart manufacturing. So that's about smart manufacturing. And Rodney, remind me, I think we're going to take questions at the end, right?
That's correct.
Okay. So CESMII, we have about $200 million to work with. Half of it comes from the Department of Energy. The other half comes from our members in terms of cash and in-kind contributions. It's a public-private setup that's housed at UCLA. Our headquarters are in Los Angeles. Our staff is about half in Los Angeles area. The other half is across the country. And our goal is to improve productivity and competitiveness through smart manufacturing. And like I said before, it's all about sensing, control, modeling, analytics, platform. And then the information piece of this is all around reducing the cost and complexity of creating these kinds of systems and then proliferating that for our manufacturers. So within our ecosystem, within our membership, we have representation from manufacturers, systems integrators, machine builders, technology providers, as well as academia and labs, and a lot of the nonprofit organizations and institutions that are part of it. We have about 210 members today, and it's been growing pretty steadily. So all that stuff is good. What have we done? If I look at like three pillars, the first pillar is all about developing smart technologies to solve hard problems for the manufacturers. So this is where we do a lot of collaborative projects, and we take a look at this oval, and then we got projects that have addressed either certain parts of the oval or the entire oval, depending on the complexity of the problem. And we focused on improving productivity, improving energy usage, quality, yield, and so on. And here are some examples that in the steel and cement industries, we've demonstrated anywhere between 10 and 25% reduction in energy usage through use of smart manufacturing technologies. The second pillar here is around accelerating smart manufacturing adoption, particularly in small and medium manufacturers and the supply chain. And here, our platform technologies have enabled anywhere from 25 to 50% reduction in the implementation costs of a smart manufacturing solution. Again, these solutions are addressing performance and productivity, but at the same time, as you proliferate those solutions, you're also reducing the cost and complexity of doing so. And this is particularly important for small manufacturers that could be part of multiple supply chains, not just one. Rodney, I think there are a few people waiting in the lobby. I don't let them in. The third pillar of this is the upskilling of the workforce through our education and training efforts. And this is around two different flavors. One is building new talent through colleges and universities. And we've worked with academia to create new curriculums that are centered around smart manufacturing with existing pathways into engineering schools, as well as two-year colleges that are training folks for just a lot of hands-on education in that field. We've also upskilled the incumbent workforce, and right now we are doing that at the rate of about 2,000 folks per year, roughly speaking. And the last piece of this is the Smart Manufacturing Innovation Center. So whatever work we do, whatever technology and curriculum that we develop for training, is being disseminated through different regions in the United States through our innovation centers. And we have 7 of those today, and they take our best practices and our technologies, and they help proliferate that in their regions. So I'm just going to briefly talk about what each of these blocks in our strategy are talking about. So this is going to be technology, knowledge, and ecosystem. And under technology, there are 2 main things that are going on. One is that we've got collaborative projects that we've used to demonstrate the impact of smart manufacturing in multiple industry verticals. 15 of them are shown here. And then we do that for small, medium, and large manufacturers. And through the 60 or so collaborative projects, we've had use cases that have demonstrated the ranges that are shown here. So about 10 to 35 in energy reduction, 10 to almost 40% improvement in productivity for manufacturers in various sectors, and then 25 to 50% in implementation costs over there. Now, the reason these range exists is that, if you're a small manufacturer and you've made an impact on their productivity, we actually got cases where they've completely eliminated quality problems. So they've completely eliminated downtime. And in those cases, those numbers are really high. So that's why you'll see some ranges in here. The second piece of technology is around the platform. So this is all about how information moves within a smart manufacturing system. The reason this becomes important is that today, a lot of the smart manufacturing systems are created by technology vendors that have their proprietary pathways of collecting the data, organizing the data, and then utilizing the data. So if you look at this stack here, at the bottom here are your physical assets. Then you have some sort of an edge that takes the data in and feeds it into a platform. And then data is accessed from that platform for different applications. So there's nothing new about this particular picture or this stack. What's new is in the manner in which the data is being collected and transmitted and stored and organized and made available, right? And that is done, in our case, we are proliferating a standards-based approach to doing that. We don't have a skin in the game in terms of proprietary technologies. We are an ecosystem of multiple technology vendors. So we can actually create best practices and specifications that others can adopt, and therefore make this ecosystem much more affordable and much more interoperable, where a best of class person from somebody who provides an HMI or SCADA system can now actually play in that same ecosystem without having to worry about proprietary technologies. So that's the basis of what we are trying to do here. And to make it better for manufacturers, we've created a smart manufacturing marketplace where we have hundreds of these, we are calling them SM profiles, smart manufacturing profiles, which is basically a reusable, standards-based, structured information model that resides in here. So you could go in and say, I want one for a CNC machine, I want one for a robotic cell, and so on and so forth. And then you can have an application that works on that same profile. And therefore, you're able to match the application with the profile, and therefore the data extraction becomes easier. So that's the story behind what we're doing in terms of reducing the cost and complexity of these systems. So take those use cases, take the technology platform, match them together, and you have a pretty good demonstration of how this can all work together. The second pillar is around education, and here what we do is our goal is to basically support the ecosystem, expand that network, train them, equip them, certify them. And we have curriculum and tools that we generate here on the left-hand side through our partners. And the partners are both in the academia as well as in the industry. And so we develop those curriculum and technologies, we verify them, and we market them. So this is all the content, and this is where it is delivered. And the way we do it is through 3 different mechanisms. One is consulting support, education support, and technology support, right? Technology we already talked about. Education support could be through curriculum that's available online, or it could be through training programs and certification programs that we have um, in our institute. And then consulting is where they're just looking for a set of experts in certain fields, and through our ecosystem, we can make those experts available to help you and guide you. And in terms of that process, we have several opportunities that raise your awareness through these demonstration days and roadshow opportunities that CESMII does across the country. We actually have a truck that goes. We also have half-a-day workshops for leadership. I mean, as you know, a lot of this thing around culture and making sure that manufacturers understand what smart manufacturing is and how it can help them, it starts at the leadership level for sponsorship. And so we have half-a-day workshops for them. We have boot camps for the folks that want to do the hands-on training. So we actually have a smart manufacturing learning kit, size of a suitcase, that you can actually take around. And then we have curriculum and software that goes along with it to do the hands-on training. And then we have an education catalog that talks about all the subject matter that's important: IoT, data, best practices in sensors and integrating for a smart manufacturing solution. We've been about a year plus in launching this smart manufacturing strategic roadmap professional training course. So this is more like train the trainer, and we have about 60 or so that have been trained, and these are the people who then become proficient at creating these roadmaps for manufacturers, and they've been certified by CESMII to do so. And then all this stuff results in implementation projects. And there are various ways in which this can be supported for manufacturers, depending on the type of project and the type of funding opportunities that they would like to pursue. And the last piece of this is the ecosystem. We have 210 members. As you can see, I won't go through all the logos here, but we have roughly 60% representation from the industry, 40% from academia, national labs, consultants, and so on, and nonprofits. It's a fairly rich ecosystem. Like I said in one of my previous slides, about 50 to 60 of these members have been involved directly in some of the collaborative projects. Others have been involved in developing our platform technologies. So it's a good family. And our innovation centers around the country, they are all listed here at the bottom, but they've been doing fantastic work in assessments and surveys. Over 1,000 of them done. We have now reached like 7,000 a year in terms of our run rate for the number of students that have been educated, and the upskilling of workers, 6,000 a year. So again, this is rapidly growing through our ecosystem of these partners. You are in the Northeast Pennsylvania area, so the closest one for you would be RPI. Okay, so that's basically the overall story of CESMII and smart manufacturing. I'll just walk over some of the use cases that'll give you some sense of how we've used smart manufacturing solutions to make improvement in things like productivity and energy usage. And this is where I bring in Mark to talk about the first slide. But before I get there, just at a high level, what I've shown is that all of these things on the left-hand side around the building block technology, the platform technology, the education and workforce, essentially what you're doing is you're ending up with an optimized manufacturing process, that has impact on things like performance, productivity, waste, yield, and quality. Now, we don't change the manufacturing process. So the way we impact energy is by making all of these other things more efficient so that you eventually have an impact in energy. And the examples that we're going to show you will basically illustrate that concept. And out of the 60 projects that we've done, we've also laid them out as an example where we've actually marched along this oval where here are some examples of where we've created new sensing technologies. Here are the examples where we've created some of the platform technologies for contextualization and analytics. On the right-hand side here is about the predictive model, and then finally bring it all together for the prescriptive model-based control of the manufacturing process. And you can see the types of industries that we've touched upon here just in these examples for this slide. A lot of cross-cutting stuff that we've been able to do. And with that, we'll go over to the first use case. So Mark, I'll have you maybe spend, 3 to 5 minutes if you want on this one, because this is really a fantastic example of how we've been able to use smart manufacturing technologies for a key industry sector.
All right, thank you, Haresh, and I appreciate the opportunity to come talk to you all here. We, over the last 4 years, have been involved with our industry partner, who happen to be Argos USA, a large cement producer. There are no small cement producers in this country. And what we were looking at in particular in this aspect is taking a look at the process that is used to create Portland cement. And this thing has been going over, over a century. We basically make it the same way we've done over these multiple decades here. There has been refining of the process as they go along. They use a lot of sensors primarily to protect the equipment that is being used in the manufacture. These are multi-million-dollar investments. But basically, the process of making cement is taking a limestone, calcining it, then taking that basically lime, calcium oxide, and then converting it into calcium silicates. And those calcium silicates, when ground, form Portland cement. And we use that in huge amounts throughout the US and actually worldwide. It's a very energy intensive process. It takes about 3.5 to 5 gigajoules per ton of cement produced. It's about 7 to 8% of all the CO2 produced in the world from industrial processes or from cement manufacture. And so we took a look at what they were doing and with our partners worked together to try and identify and get a better handle on what's really happening within the process. So there is 2 major highly thermal processes involved in here. They know roughly what the chemical reactions that are taking place in there, but they don't have a good handle on what's happening throughout. So what we did was develop a digital twin. We started with multi-physics modeling, and because attempts have been made in the past just to use pure smart manufacturing techniques, particularly machine learning techniques based off of data, and they are found to be less than effective overall. And what they found was you need to understand the process, and what our premise was in this whole project was that they were putting more energy than they needed into the process because they didn't understand it all that well. And they have found through trial and error, basically, over multiple years, et cetera, that if they put this amount of energy in, they get good quality out. So quality was a key focus in the industry. How do we produce that? They do that by overdriving the kilns and the process to ensure a certain quality out there. So what we did is saying, okay, if we did a better job of estimating what's happening within all of the process in there, developing a better understanding and then measuring what's going on and then using that to be able to predict what's going on, we can then throttle back the energy used in the system. So we did a lot of multi-physics modeling. We developed a lab kiln, the only one in the world that we are aware of that simulates the rotary process within the cement kiln at this level, at this scale down version. we developed a better idea of what the thermal regimes were in the kiln initially. We then developed a model predictive controller, so we were able to predict that. We used machine learning language and different aspects to go in and take real kiln data from our partner, one of our partners' kilns in the US. And we went in there and we predicted what was going on. We used 3 years of data, went through a variety of different algorithms to get the best prediction and most accurate prediction out of that. And then we took that down to one of their kilns. And one of the things you have to understand with the industry is this is a very chaotic, very hard to control process. It takes about 6 months to a year to fully train an operator on one of these kilns. And so they're very conservative in what they'll allow you to do, and nothing is automated. It's all real-time controlled by an operator. 2 of them are in the kiln that we're at, that's standard. And so there's a lot of people twisting dials, metaphorically, that's all done virtually on computer screens now, but they're very hands-on in the process. And that is to keep everything stable. So we developed an advisory predictive controller that took the basic process, was able to predict the quality of the output from that process, depending on the parameters in there. And then we build an algorithm in there that says, okay, let's throttle back the energy that we're inputting in there while maintaining a fixed amount of quality within the bandwidth that would be acceptable by industry. And let's see what we could do. And we simulated all the way up to about 30% reduction in energy used in there. We went and deployed them, and we got about 10% reduction in the 2 days they allowed us to play with their kiln. You have to understand that days run is $1 million investment. If we muck it up, that's what they're throwing out. And so they got pretty leery on that, but we did pretty good with 10%. But what we found was they didn't tell us that they had hooked in line their calciner, and that whole thing is a loop system. So we went back in a second investigation, and we incorporated the calciner into that process. We were able then to deploy in the middle of the edge of a hurricane down in Alabama to them, and we got around 13% to 15% before they shut us down because they just didn't believe we were producing good quality after that. But we were quite successful in that. One of the problems that we ran into is the people that we were working with were 100% behind us. Then they got sold twice during the project. So they're now owned by the third set of people, which makes it a little harder to convince there. And we're hopeful that we just finished that off in September last year. And it was a really good interaction. 2 things I want to say on that. It was really a collaborative effort. Our partner had a research scientist with their R&D wing. He actually came to the University of Louisville, went on half-time with them and half-time here, and he got his PhD out of this process. So I consider that a significant win, and he's out in the cement industry working for another company who poached him away. So it was a really good exercise. We've got a really good multidisciplinary team involved in that. And we had a great group of partnership there working together on this. So it was a great learning experience. There's lots of opportunity out there with industry. And it was a great learning experience for me as well.
Great. Thank you, Mark, for summarizing that project. I think you and your team have been great partners for CESMII, so I appreciate all the work that you've done. Thank you. I'm going to show you a couple other cases. Mark, you're welcome to hang on, and if there are questions at the end, you could probably help answer as well if you have time. Otherwise, I'll take them on.
I'll stay.
And then here's an example of the steel industry. This is where I said that, they actually, for the steel industry, if you're familiar, the continuous casting process is used by, I don't know what the number is, but like 90% of steel producers or something like that now. And one of the critical things there is to be able to detect where the molten metal becomes solid in this process. And that controls the majority degree the quality of the slab that comes out. And so one of the challenges there was to be able to measure exactly where that occurs and in what way. So there are two different sensors that were created by Missouri Science and Technology. One was a 3D displacement sensor that sits on one of these wedges, and then also an optical strain sensor that also sits around that. Now they have to operate in this harsh environment. So that was one of the collaborative projects that they did. And then Purdue developed a digital twin of the caster so that you could actually run it, hook it up to real-time data, and then use it as a tool for engineers, both in process development as well as in maintenance, to be able to do that predictively. So again, a lot of good work was done here collaboratively, model development, sensor development, and then bringing it together. This is something that, if you take the steel industry numbers, the potential impact of something like this would be just really huge. You're talking about, $2 million savings per strand. So this would be like one strand, one unit that creates that. So a lot of good work done by the team here. And you can see some similarities here between this and what was done with Mark's team and cement. Here's another example in the chemical industry. So the air separation unit is fairly common for the oil and gas and air sectors. And then there's the challenge here was that, again, the process is not 100% well understood. They did some modeling of the air separation unit through multi-physics models. But those models take, forever to run, right? So you have to create what are called surrogate models that run in the control environment. So all these digital twins that were created were then transformed into models that could run in real time. And then one of our project partners created a real-time system for the getting the data from the ASU on a platform, and then the predictive models were made to connect to that so that you could have a real-time assessment of how the models are doing and then provide the ability to adjust the process based on that. Again, very similar themes here. This came from our industry member. They said that, a small change in the operating efficiency, I think they said even 1%, would be worth about $10 million a year for one manufacturer. So huge impact just in little changes that can be made. So this is an example in the food industry. What's shown here is the energy usage in the different steps as you make, in this case, it was yogurt. And then the idea behind this was that you actually measure things like current and power on a whole variety of equipment like pumps and mixers and so motors. And then you bring it together in a very comprehensive energy assessment dashboard. And then through that, they are able to determine where there are gaps in efficiencies. So are there, pieces of equipment that can be optimized because they tend to use higher amount of energy than you would have expected? And there are surprises there, obviously. So then you use machine learning models to actually create some analytic tools. And then through those tools, then you monitor the energy and then you make some improvements based on that. One of the outputs, side outputs, was to actually come up with this labeling scheme where you could actually figure out how much energy is being used by what product. And that helped them narrow things down and make it more efficient. The other thing they did here is that they did this in two plants. The first plant actually had the sensors on the ground. The second plant didn't. but they used the same model from the first plant, applied it to the second plant, and it came out to be pretty close to what they would have wanted. Of course, some tweaking is required as always, but they got them started pretty quickly. I think this is maybe the second to last example. This is in composite brake manufacturing. Again, a pretty well-balanced collaborative team that worked on this. This was more around some of the thermal processes that they have in chemical vapor process for this composite manufacturing. The theme is very similar again. The team came up with predictive models that actually computed the energy usage in each of the steps. And then also they created a machine learning based anomaly detection algorithm for the set of furnaces in this. So their expectation was to again hit the 15% target in energy consumption. I think I don't have the last report on this one, but they were pretty close to getting that number. I think they reached about 12 or 13% in doing that. And the last example is where a lot of the predictive modeling was actually used to create what's called a soft sensor. So in this case, it's pulp and paper. The pulp comes in, and then they have this washing process where a defoamer is used and water is used, and then the pulp comes out at the other end. But there's no intrinsic measurement available for figuring out how much of air is being entrained in this. And air entrainment in this process is critical for the quality of the pulp that comes out. And so what they did is they took all the measurements around the process and then created a machine learning model that would then predict what the percent air entrainment is, and then use that as a sensor, quote unquote sensor, to tie it up in a control system. And again, in this case, there's some huge impact on defoamer usage, like 72% reduction. So. Okay, so that was my last slide. I know we went through the examples a little quicker, but I wanted to give some time for Q&A so that we can also have some discussions around any content that you've seen today.
Thank you so much, Haresh and Mark. That was great. There is a question in the chat, but before we do that one, I would like to ask a question about how can state energy offices and other agencies and programs engage with CESMII, not only government agencies, but also technical and business assistance providers in the States. What's the best way to work with you and your network?
Yeah, there's a couple of ways. I mean, we actually have a memorandum of understanding with the MEP network. So we directly work with them. They have been part of some of our regional events and road shows. And through them, we get connected through the local ecosystems, whether they are of the manufacturers or the nonprofits and other agencies that are working with them in that region. We are also, CESMII is now the technical assistance field manager for the state manufacturing leadership program through MESC. I think many of you may be familiar with that particular organization in DOE. And so that's another mechanism through which we actually get engaged with the folks that you're mentioning. Mark, I know, is part of an industrial assessment center, which is at Louisville. So again, through that, we have connections in there. And then our membership model is kind of set up in a way that you could actually have any of those agencies and partners come in at whatever level is appropriate for them. There's a simple observer level, which is really, really inexpensive. And you could be part of the discussions. You could engage with the experts. You could engage with the folks that have done projects with us, etc., and then gain some information through that interaction.
Okay, that's great. And also, I guess that answers the question as to technical assistance programs that are not already in your network or not the MEPs. They can use the MEPs or these other ways to get to you. So that sounds good.
Yeah.
So there is a question in the chat from Pavitra from ACEEE regarding are the results from the Argos project publicly available? But before you answer that, I guess maybe Mark, the wider question is how is intellectual property handled? So you work for Argos or whoever the owner is now, and you've developed a solution for them. So that's great, but they may not be so desirous of you sharing that with their competitors. So
Okay.
how is that dealt with?
So as far as CESMII is concerned, the guidance, not the guidance, the policy that we have is that when we fund a project, a collaborative project, the agreement is that the IP is owned by the project team. CESMII doesn't own it. And then what we ask in return is that that particular technology is available for members to try out within the CESMII framework, CESMII membership framework. As long as they're members, they can try it out on a trial basis for R&D, but they cannot use it for production purposes unless and until they actually obtain a license from the project team. So that's the arrangement we have. There are sensitivities, obviously. It's up to the project team to say yes or no, right, to making it available for other companies in a production framework. But if the other company is part of CESMII as a member, then there has to be an agreement that is much softer where they could actually try things out and assess some of those technologies.
Okay, good. So Pavitra's real question is, are the results from the Argos project publicly available?
There right now there are two papers that have been published last year, year prior to that in a journal. We're working on a third one for this last go round. Hopefully the PhD student will finish it off. He's defending in about 3 weeks. So
Yep.
yeah, we can get that available. As Haresh had indicated, we have a basic case study there where we have put data in. It's owned by Argos, but you can go and try it out and see how it simulates and predicts what's going on it basically goes through using existing data, and you can play around with it. But to fit that to yours will take some effort, and that would be part of what CESMII does is then provide services that you can engage with these particular manufacturers to get them implemented if an agreement for deployment is made with the owner of the IP. So.
Okay, great. Other questions I invite the audience to ask, and while they're maybe cogitating on questions, following up, Haresh, on the Smart Manufacturing Leadership Program, could you tell us more about that? We have previously shared the announcement of the funding opportunity, but we haven't had a chance to check in. I guess now you'd be the right person to check in on how that is going and where it's
Yeah, so
headed.
we don't administer that program. I mean, the funding comes from DOE through MESC. But what they did is they said, okay, these state initiatives are all working towards smart manufacturing for small manufacturers and the regional ecosystems. To have CESMII come in more as a umbrella oversight so that it's not all one-off things that are happening, that is happening in some coordinated fashion. So we provide guidance on the best practices. We educate them on what's available, what's appropriate. And there are 12 states that are part of that program today. And then we are the field. I keep losing this, but it's technical assistance field manager. I think that's the title that we have. So we provide. We are doing like weekly calls and monthly community of engagement kind of interactions with them to make things available through through our training programs, through our through the work that we've done on different projects and so on and so forth, that's made available to them as part of what they may want to pursue.
Okay. So this harkens back to the earlier question about engagement with you. You did mention that there are memberships at various levels.
Mhm.
But for an individual firm or for that matter, a technical assistance program, is there any costs for at least an initial consultation and at what point where might costs be incurred? Say I am a metal finishing operation somewhere and I want to engage with you and I have a small
Yeah.
margin. How do I
Yeah.
work with you that's affordable?
Yeah, so I would recommend just contacting our business development lead, Steve Winsky, and he would get us started. So he actually has a lot of these initial conversations with potential members, and that doesn't cost you anything. That's an initial engagement. We can, give you the information you need so you can make the decision, and we can also make a recommendation on what level of membership might be appropriate for you. So that's the first step. And then you can determine, I think if you go to the website, you'll see the different membership levels and then, see what the pros and cons are. You have something like an observer level where you're just there observing, but then you also have the tier 3 where you're part of the board, you're part of the technical committee, you can lead multiple projects if the funding comes through CESMII. So there are just variations in that. And it also changes whether you're academia or industry.
Okay.
Related to that too, so there's some effort to port some of the smart manufacturing ideas that are developed by CESMII down into the services that the ITAC programs are providing regionally. I'm working with the MEA group, and we've got 5 ITACs working together to develop a curriculum, and then providing cursory evaluations when we do our energy assessments to see if we can look at opportunities for smart manufacturing as well. That's all dovetailed with CESMII, and we're working together with them to make sure that we're consistent with that.
Great. That's good to hear, and I hope you will let us know of any results that come from that because that's very much been a theme of ours to have the different programs work together in various ways.
Yeah, well,
Um,
we're waiting for the DOE to give us the money, but we'll see how it goes.
yeah. Richard Hart has a question. I could read it off, but I would actually invite him to speak to his question and his comment.
Great. Thank you. Thanks, Rodney. We see that you've got some great outcomes here that are energy sort of savings, and therefore I would imagine utilities and regulators would be interested in using those results, developing programs around smart manufacturing. In order to do that, they might need to get a little bit more data from the projects. You mentioned being able to maybe use papers that were published. I'm just wondering, do they need to become members to kind of get inside the information loop in CESMII, or is there a series of standard published papers that utilities and regulators can turn to?
So I think for specific cases like what Mark was saying, I mean, the published content is there in papers. So that's, of course, free for use. But to really get down to the details of the technical aspects of it as to how it was done and all that stuff, you would have to be either members or we have to work out some arrangement that protects the IP of the project teams.
Is that responsive, Richard?
Yes, thank you.
Okay. Last call for questions. I see we are a little past the top of the hour. And I see no hands up and no additional entries into the chat. So Haresh and Mark, thank you so much for joining us. And the rest of you, thank you very much for your participation. This is great. We look forward to keeping in touch and please keep us apprised of your progress. And for the working group and the other participants, thank you for participating. And we welcome additional exchange and keeping in touch. And we certainly welcome thoughts about what the next webinar should cover.
All right. Well,
So,
thank you for the opportunity, sir.
our
Thank you all.
pleasure. Thank you so much, and take care and have a great rest of the day and a good week. Bye
Thank you.
now.
Bye-bye.